Hello, my name is Ray. I'm the Ray in the Ray code. In this video, I'll be covering the adapter design pattern, and I'll be using Java. Not JavaScript, but Java. Although I use tutorials in JavaScript and other programming languages, this video will be in Java. I use other programming languages to cover this design pattern. I have used this particular programming language, Java, to cover other design patterns that are mentioned by the game forum. I have put timestamps in the margin so you may navigate to the section you desire most. My favorite is SWOT analysis. Please like this video, leave a comment, and subscribe. The Ray Code can be found on many social media platforms. Please search them out and become a Ray the Code groupie. The adapter design pattern is classified among the structural design patterns. The main role is to act as a bridge between two incompatible interfaces, allowing them to work together. It achieves this by creating a new interface, the adapter, which enables one existing class to be used with the other classes without changing its source code. The pattern is essentially about converting the interface of one class into the interface expected by the client. Integration with legacy code. Java has a rich history and many legacy systems built on older systems. The adapter pattern can help integrate older systems or components with newer implementations without a total rewrite, maximizing the utility of existing code. Facilitating third-party libraries. Java's vast ecosystem contains numerous third-party libraries. Sometimes the interface provided by such a library might not fit directly with the existing system. Adapters can bridge this gap, making integration smoother. Enhance code reusability. If a Java developer has components with necessary functionalities that don't match the current system interface, an adapter can mold the existing components interface, leading to an increased usability rather than starting from scratch. Promotion of modularity. By ensuring that interface adaptation is separate from the core functionality of the adapter pattern fosters modularity. This separation makes the codebase more maintainable and understandable. Incremental system evolution. As systems grow and evolve, they might need to incorporate new methods or techniques. The adapter pattern provides a flexible way to bring new functionalities without destabilizing established workflows. Open-close principle adherence. One of the solid principles, the open-close principle, posits that classes should be open for extension but closed for modification. The adapter pattern aligns with this principle, enabling extension without altering established code. Simplification of interfaces. Some interfaces can be unwieldy or too granular. An adapter offers a means to simplify or tailor these interfaces, making them more convenient for the rest of the application to interact with. Multiple interface adaptations. Given a single interface, it's possible to design multiple adapters. Each ensures compatibility with different systems. This versatility ensures broad adaptability and system compatibility. Giving Java's prominence in both enterprise and open source landscapes, its rich library ecosystem, and its long-standing history, understanding the adapter design pattern is paramount. It equips Java developers with a toolset to integrate diverse systems, leverage existing codebases, and build adaptable software that can evolve without extensive disruptions. Structural pattern adapter for Java students. Target defines the interface the client expects to use, represents the standard way objects should behave, used directly by the client. Client works with objects through the target interface, does not know about the adaptee's interface, uses the adapter to interact with the adaptee. Adaptee has an existing interface that is compatible with target, contains useful behavior the client needs, cannot be changed easily. Adapter implements target interface. Translates client's request into adaptee calls. Connects incompatible interfaces safely. Hello, my name is Ray, and yes, I'm the Ray in the Ray code. In this video, I plan to give you an example of the design pattern called adapter. I'll be using Java. I'll be sticking close to the naming convention that was given by the Gang of Four. We start with an interface we call target. Target is the interface that client expects. When you use this interface, you need to have a request method. Let's create a class we call adaptee. The adaptee will be an existing class with an incompatible interface. We have a private string we call the adaptee value. Next, we have a constructor which sets this adaptee to the value of the adaptee we just passed in. We create the specific request from which we return the string adaptee.specificRequest, adaptee value plus the adaptee value, and we return the adaptee value. And last, we set adaptee value to adaptee value we pass in. Now, let's create a class we call adapter. The adapter implements the target and wraps the adaptee. The adapter implements the target interface. The adapter must implement the methods required by target. Target only requires one method, request, so I'll have it auto-generated. Request returns a string, so we create a private string variable called prefix. We declare the adapter with the adaptee we passed in. We store the reference so request can delegate it to the specific request. We set this prefix to adapter default prefix. We add a set prefix method which takes a string prefix. Inside a request, we set the adaptee result to the adaptee specific request. We return prefix translated adaptee result. Next, we create a class we call target. Client holds a reference to target. So we have a private variable named target that we will instantiate. For the client, we set this target to target. We have a method named operation. Operation will print the result of calling the target interface. Now let's go to the main method for our demo. We create the adaptee with an initial internal value, wrap the adaptee with an adapter, create the client depending only on the target. We first run default adapter and we system out print line adaptee internal value baseline. We change a variable on the adapter with set adapter set prefix. Second call adapter prefix change. Prove adaptee's internal value is preserved. We set adaptee value change directly. Third call adaptee change directly. Now let's run. We get adaptee default prefix translated, adaptee specific request, adaptee value original, adaptee value. Second call, adapter prefix change. Adapter update prefix translates adaptee specific request. Adaptee value original. Adaptee value should be unchanged. Adaptee original value. Third call, adaptee change directly. Adapter update prefix translate. Adaptee specific request. Adaptee update value change directly. Adaptee with internal value now change. Adaptee value change directly. My name is Ray, always with a smile. SWOT analysis of the adapter design pattern using Java. Strengths. Interface compatibility. Adapts incompatible interfaces, facilitating integration with third-party Java libraries. Code reusability. Reuses existing implementations by wrapping them in adapters. Flexibility. Decouples client and adapted interface, enhancing flexibility. Weaknesses. Added interaction. Extra layers might introduce performance overhead. Complexity for beginners. New developers may struggle to identify when to use adapters. Limited lifetime. Adapters become redundant if legacy code is rewritten. Opportunities. Legacy integration helps integrate legacy systems into modern Java applications. API wrapping wraps third-party APIs for consistent usage in projects. Cross cross-platform support, simplifies adapting applications to different Java runtime environments. T. Threats. Overuse risk. Overusing adapters might clutter the codebase. Direct solutions. Refactoring may eliminate the need for adapters in some cases. Performance bottleneck. Adapter layers can slow performance in real-time systems. Well, that was my video. Please give this video a like. I worked hard to create it. Leave a comment and find me on all my social media platforms. But most of all, tell a friend the Ray Code is awesome.